Hello, everyone. I am Riches. Well, at the moment, I'm a DevOps engineer. I'll get to why I said at the moment later on. Um, so I like similarly mentioned earlier, I have a first degree in chemical engineering before switching into cloud and DevOps. So without wasting much time, I'll just get into it. And also, I'd just like to, put this out there that irrespective of what you hear, me say whether terms or I use or tools or anything, you shouldn't feel pressured as long as you have a conviction to go on this path. It takes time and it's a process. So even if some things, I don't know, sound like jargons or don't make sense, you shouldn't get scared. Like it's okay to feel that way, but like don't get discouraged, but like keep going. Basically, simply putting it as small, insignificant, seemingly insignificant efforts when done over a period of time leads to gigantic results. So with that in mind, I'll get into it. Can you please confirm if you can see um, my screen showing what is DevOps?
Yes, your screen is showing and it's moving.
Okay,
Start with there. It's there
thank
now.
you. So I'll start with like definition of DevOps. So in the tech space, there's been a debate: is DevOps actually a role or is it a practice? So because it depends on the company and how they view DevOps. Because some people, you would see some people call the role DevOps engineer. You see some people just term it as a practice, and then they have like software engineers and say they're using DevOps practices. So going with that, DevOps is a culture and set of practices that bridge software development and IT operations. That's where the dev and the ops come together to form DevOps. So basically, going back to when Tim Len was presenting about software development, that's where the software engineers or developers write the code. And then usually you have like IT operations, the ops. Like I think someone asked a question about being a sysadmin and wanting to pivot into cloud. So I think they handle some part of the operations, which is to set up the server and like probably like deploy. But then DevOps kind of like bridges the gap and brings these two together. So also it automates the path from code to production, which is what I just explained. Basically, when software code is written, the DevOps makes it available on the internet for end users to see and access, also making it resilient and highly reliable and available. So yeah, I've covered that. Enables fast, reliable delivery of value to users and also fosters collaboration, ownership, and continuous feedback. So DevOps lifecycle and key practices. So from the life cycle, we have the stage where you plan what's your or the pipeline. We call it pipeline. That's like the steps in DevOps, or like what you like to deploy or how you want your pipeline to be. And then you have the code. You have the building stage, which is where there are a couple of commands or like things involved. So where you kind of like build your code with like packages to that makes it work properly in a production setting. So production setting simply means because in software development there are like different environments. We have like the test environment, and which is where software developers test their code, make sure it's working fine, because you do not want to deploy a website and have your customers go and meet error where it's something like 502 error, or like an error that the website is not working. You don't want that here. So you need to have like an environment where you test your website before sending it out for people to use. So you have to release, the deployed, operate, and monitor. Then there are like core practices in DevOps, which is like the CI and CD, which is continuous integration. And CD can either be continuous delivery or continuous deployment. I didn't include that here. But the difference basically, so the CI process is like where you build the software and like package it, either the build process basically, and whether in containers or whatnot. And then the delivery aspect or deployment is actually updating the website and taking it to production. So, for example, you might see some websites where you go today and the interface or how it looks is one way, and then you go the next day and you see a new interface. I mean, simply put, something like you update your OS of your phone and then you see a new look. So there was a new deployment there. So and difference between delivery, continuous delivery and deployment is just that I think during delivery there's a manual process in the point of like sending it out to production. That's after building, and then deployment actually just skips that manual process and everything's automated. Then you have infrastructure as code. This is because when you think about DevOps, it's just think automation. Basically, how can we make things easier? How can we automate things we can skip manual processes that takes time? So infrastructure as code. I'll get into the tools later, but then it's basically having like a template where your so infrastructure in this term can be like the last speaker when we spoke about AWS, so using like cloud platforms and resources on them. So you can have like a cloud infrastructure, which is like your system design or like your infrastructure setup, which is like either using a database with an EC2 with maybe network gateways or anything. So basically provisioning it, you have to provision these resources to use them. So it can be done manually, which is by like going to AWS website and just setting provisioning things. But then there can be a problem with that. That's with like consistency, where you might provision something and then you have to like go through it manually all over again. But then infrastructure as code helps us have this template such that when we need to replicate that kind of thing, it's easy to like just go there and maybe input a name and then just apply it, and every other thing is already structured and then just deploys. And also when you need to delete something, you can do it through this IAC tool to make it easier, and then also helps you like monitor the resources you have, because sometimes you may like cloud services have different regions. You may deploy something in a different region or somewhere, and then you're no longer using it, and then you can't keep track of it. So you might forget it there, and then that costs you money. So IEC2 can also help you, like, keep this in check. Then you have automated testing and rollbacks. Then that's like rollbacks, like in terms of like disaster, that you can like go back to the previous working version. And then we have observability and incidents response. Then we have some popular tools and technologies, because the world of DevOps, I'll term it as an ocean. You can compare it to an ocean, because there are so many tools available on the market. I mean, simply put, so okay, I'll go through them one by one. And so as a DevOps engineer, you shouldn't feel pressured to know every single tool, because it's based off the company's preference. You might go to a company today and they're using tool A, then you apply for a different job, a company is using tool B. But so these tools, they kind of like work in a similar way, most of them. So it's about just getting used to how this one works. And sometimes in an interview or something, you just feel free to tell them, oh, I'm experienced using this one. Is it okay if I learn this, that you can catch up and whatnot? Don't feel pressured about they have to know everything or whatnot. So because they understand that it's like that. So we have like version control, which is like popular one is like everything. Most of them use Git. So popular ones are like GitHub, GitLab, which helps with collaboration. That's where like software engineers write code, or teams, because they might have like different features they're working on, and they can't, wait for one person to just finish before picking up. So it helps with collaboration of like people working on different parts so that they can like be more productive and like faster. Then we have like CI tools like Jenkins, GitHub Actions or GitLab Actions. So we have containers and orchestration. So I mean, in the past, most deployments were done on like big servers. So sometimes the server is just there and running, and you know it's either over provisioned. That's like where you have more resources than what you actually need, and I mean that's not frugal or like in the real sense of things, because you are literally paying for more than what you require. So and also you don't need the entire VM. So but like containers help to like package these things in like lightweight or like smaller versions that it's easier to like scale up as well, because the VMs themselves are also expensive. So containers are like lighter weight deployment tools that help you, package the software in its smaller parts so that it can also like replicate and scale on on a bigger scale. So examples of container tools are like Docker or like Podman. So that's like the container aspect. Then you also have the orchestration aspect, which is having a tool to help, with the replication or scalability, which we have tools like Kubernetes or like Amazon ECS, which is on AWS cloud platform. And then we have like Nomad, HashiCorp Nomad. So so reason why, another thing why you might have like so many tools is because sometimes people keep improving and like working on the tools to see better ways of like using them. So we have like platforms as well, like when we spoke earlier, we have AWS, Azure, Google Cloud, and then we have infrastructure as code tools like Terraform, Pulumi, and CloudFormation. Then we have monitoring and observability, where we have tools like Prometheus, Grafana, Datadog, basically taking the metrics from like your resources and making sure they're up and always running, you know. So because it's essential to make sure the customers are happy. So why should you consider career in DevOps? It's in high demand, across industries, and the salary is really competitive. Um, Also, you have like a blend of software engineering, cloud, and operations, and you have the opportunity to drive real world impact and reliability. So, reason why I said at the moment I'm a DevOps engineer, because in the world of DevOps, you can have different companies have like different title for like roles that do like similar things to DevOps engineers. Like you can have system development engineer, which I know Amazon has. Then you have cloud engineer, you have site reliability engineer, which is SRE, and in some cases you have like platform engineer. So to get started, there are like basic things that you need to skills you need to have, like having one scripting programming language, like it could be Python or like Bash or Golang. Then you also need to be good with Git and then Linux fundamentals. So like the person who is already a system administrator, she should be good with like Linux already. So that's covered. Then you also need to like work with Docker and like CI/CD tools, basically, because those are like core concepts of like DevOps. And then sorry about the part where I said you have to earn or like a cloud or Kubernetes certification. I mean, it's good to earn, but it's not essential. It's not primary. So the primary thing you need is your experience, basically. So the certification part is I do some of them, and it helps me like test my skill. So after learning, it's a way for me to know, okay, I'm this good. If the professional body like Linux Foundation or AWS themselves test me and I pass, I can tell myself that okay, I'm good with this. And also some companies, like I said, the primary thing for them as well is experience. But having certificates is a way to show them that I actually know this thing, like a proof. So yeah, I think that would be all for this. That's just a brief summary. I tried to break it down. So if you have any questions, yeah, thank you.
Thank you very much. I think, do we have any question? Let me see if anyone is raising their hands. We don't have no hand raised yet.
I have a question.
Please go ahead, sir.
So for this class, Riches is going to be teaching the class, and Wumi is going to be probably supporting people maybe after class or they have a question. So to you, what do you think will be the timeline to, I know the certification, people might need to study on their own to get the certification, but in training people, because and getting the real world experience that they need to be able to get a job. So what do you think would be the timeline for them to be able to acquire this skill?
Okay, thank you. That's a very good question. Like I mentioned earlier, DevOps is really wide. Like I'm not saying this to scare you. It's just a truth about it, and try not to feel pressured. I can't quite give a definite timeline because, to be honest, it's a lot depends on your dedication and devotion to learning and going about it. Because I use myself as an example. I didn't come from a computer science background, but when I started initially, it seemed difficult because I saw things that I don't know didn't look normal to me, but I just kept going at it. So you really have to like keep at it, and it will keep getting like clearer to you. And but what I can do is that like fundamentals like learning Linux or a scripting language or version control or like containers. So what I can do is like give the basics from every major aspect of DevOps, and um, everyone who is interested in this course will have to, put in that extra effort in like working on projects, because practical is very important. Practical helps a lot. So I'll also try to get like some practical projects that people can like put their hands on to get their hands dirty on, and that will help better assimilation.
Okay, thank you.